Okay, what if I told you that one of the smartest solutions to our clean energy needs isn't on land at all, but floating on the very water that covers, 71% of our planet? It sounds a little like science fiction, I know, but it's happening right now. So let's dive in. First, let's set the stage. The only reason we're having this conversation is because solar power has gotten ridiculously cheap. I mean, look at this. In the last decade or so, the price has just cratered, dropping from over $370 per megawatt hour to less than 70. It's literally one of the cheapest ways to make electricity on Earth.
So that's the big question, isn't it? If it's so affordable and so good, why isn't everything covered in solar panels? What's the catch?
Well, the answer is actually pretty simple, and it's a problem we all get: real estate. To generate a truly massive amount of power, solar farms need a massive amount of land. And that's land we might need for other stuff, like growing food, building houses, or just leaving nature alone.
This problem gets super critical in places where space is at a premium. Take a country like Singapore. The land there is so valuable that paving over huge areas for solar panels, well, it's just not going to happen. It's not a practical choice. So they had to get creative. And that creativity led to the brilliant idea at the heart of all this. Instead of fighting for precious space on land, why not use the huge untapped surfaces of our lakes and reservoirs?
It's a technology with a kinda cool name: photovoltaics. And yeah, it's exactly what it sounds like. You take photovoltaic solar panels, you mount them on these floating platforms, and you create these huge energy-making islands on calm bodies of water.
And this brings me to my absolute favorite analogy for this. Think of it like a water-cooled gaming PC. You see, putting solar panels on water isn't just about saving space. That water has a natural cooling effect. And just like with a high-end computer, a cooler system is a more efficient system. So this isn't just some drawing on a whiteboard. It's being built in the real world, from reservoirs in Portugal all the way to Singapore. Let's get into the nitty-gritty of how these floating power plants actually work.
The engineering here is actually pretty clever. The panels themselves sit on these floats made from a super tough plastic that's built to resist sun and water damage for decades. The whole thing is then anchored to the bottom of the reservoir so it doesn't float away. And of course, waterproof cables send all that clean juice back to the grid. Oh, and the best part? For maintenance, they fly drones over it to check for any issues, way faster and cheaper.
And the scale we're talking about can be just mind-boggling. That farm in Singapore's Tenjak Reservoir, it has 122,000 solar panels. To give you an idea of what that looks like, it covers an area the size of 45 football fields. It is a massive, massive project, and it's built to last 25 years before its performance really starts to dip. Okay, this is where it gets really, really interesting. We've talked about saving land, we've talked about the cooling effect, but that is just scratching the surface. What photovoltaics create is this amazing symbiotic relationship where the panels and the water actually help each other out. It's this perfect two-way street. So for the panels, that water cooling can boost their efficiency by up to 10%. And get this, if you build on a reservoir that already has a dam, you can often just plug right into the existing power lines. That's a huge money saver. But then, for the water, the benefits are just as big. The shade from all those panels dramatically cuts down on evaporation. One study figured that globally, photovoltaics could save over 100 cubic kilometers of water every single year. Plus, that shade stops nasty algae from growing. It is a total win-win. But of course, no technology is perfect. As amazing as this sounds, it's still pretty new, and there's some big challenges to figure out before we start seeing these things everywhere. So let's be real about the trade-offs. The big one right now is money. It's just more expensive to build a floating solar farm than one on the ground. For now, the tech is also pretty much limited to calm water, like lakes. The open ocean is just way too rough. And then there are some unique maintenance problems, like birds deciding your multi-million-dollar panels are the perfect public restroom. And yes, that actually hurts efficiency. And this number really puts it all into perspective. With all this potential, it's estimated that less than 1% of all the solar power in the world is floating. We are right at the very beginning of this story. But that's the exciting part, right? Every single one of those challenges is just an engineering puzzle waiting for a clever solution. And that's exactly what's happening. So, you've got a bird poop problem? Engineers are working on autonomous, AI-powered cleaning bots. Check.
The panels are stuck at one angle and not getting enough sun. They're designing systems that track the sun across the sky, just like a sunflower, which could boost output by a third. And that biggest challenge of all, the angry ocean? Researchers are developing breakwater systems that could be built right alongside the panels, powerful enough to cut wave height by 90%. Suddenly, ocean-based farms don't seem so crazy.
And that leads to this really incredible vision for what could be. As the technology gets better and cheaper, that line between what's possible and what's science fiction, it just gets blurrier. The ocean is a massive challenge, for sure, but it's a challenge that people are actively trying to solve right now. So I'll leave you with this to chew on. We started this journey on quiet little lakes and reservoirs. But the real prize, the ultimate goal, is the vast untapped energy of the ocean itself. With more innovation, could the very thing that covers most of our world become its single biggest source of clean power? The future's looking pretty bright. And you know what? It's looking pretty blue.